So now we move on to the programme, and our first speaker is Professor Mary Garson from the University of Queensland, where she is now Emeritus Professor. She worked with Jim and did her PhD from 1974 to 77. And she's been the recipient of many awards and honours, and it's a real pleasure to have her here. I think I should also add that she is the incoming Vice President and Chair-elect of UPATH. So I say, go Mary, this is brilliant. Her talk today is entitled After Cambridge, the Chemistry Got Wilder. And we're just doing a few little technical bits here, and then I'll hand over to Mary.
Thank you very much, Helen, and thank you everybody who's here, but in particular, can I thank Alison, Helen and Barry. One of you sent me an email. If you happen to be in England, would you like to come and give a talk? And I literally went, what do you mean if I happen to be in England? I am coming to England. And I think Helen has explained the reason. It's because of Jim. It's because of how special he was to all of us, not just me being one of the early people. I wouldn't be where I am now, doing what I'm doing now, if it hadn't been for the start that he gave me in life. I'm probably not going to get to talk about my current work, so I thought I'd give you a little sort of synopsis. And I changed the title. Originally I said The Chemistry Got Wilder, but actually you can see it got wetter, right? And I frequently say to students, you know, when I was a third-year student in Lentsfield Road, I had no idea that I would have to go off and learn to scuba dive, that I would get to do all this exotic stuff on the Great Barrier Reef. And I learnt then that you keep on learning and doing new things all the way through your career. Now, if I can operate Finian's, that's me in the middle, by the way. All right. So I've just got to read this a little bit out because otherwise it's too important to me. So 1971-74 was my undergraduate period. I was at Newnham College. And in a moment, I'm going to show you a snapshot from one of Jim's lectures, because I've still got them. Then I did my PhD with him, and then after that, I went off to Italy. And during that year, I think that Jim tore his hair out. He could see that maybe I'd got some potential, and I seemed to be wasting it by going off in Europe and learning a foreign language. So he recruited me back to Cambridge, and I did a postdoctoral fellowship at New Hall. And from that point on, I've really considered him to be my mentor. Of 1981, thereafter, he was very much a friend. And as Helen said, he was a natural champion for women in science. And I think the other part of the equation, Helen, that we all had was this was our day job, but at night we went back to a college. And in my case, I went back to a women's college, to Newnham or to New Hall, where there was a community of strong women who valued scholarship and learning. And that's what helped to set us up for the future. All right, so let me just show you a few pictures. So here we go, 1972. This is the front page of Jim's lecture notes, section D. Stuart Warren had started off. There's no cover sheet. There's no sort of who's doing what. It's just straight in this section I will do. And he was a good lecturer. He not as charismatic as some of the others, but he captured my attention. But now move on to the right hand. In 1974, when we were doing part 2, we were kind of guinea pigs for a new way of organising the lecture structure. We had sort of modules, blocks of 16 lectures, and there was one on bioorganic chemistry. So who could not become a natural product chemist or a bioorganic chemist when your set of lectures was Jim starting off? And notice again, of course, that the structures are hand-drawn, and you've got my little scribble around it as well, but at least the actual words are typed this time. And Jim was followed by John Harley Mason. I think there's a link to Ian here, isn't there, right? who grudgingly told us that NMR might be useful for doing structural elucidation, right? And then Dudley, who'd just come back from Geneva, came on board and told us about peptide sequencing. And then finally, Alan Battersby. I mean, who could not become a bioorganic chemist with that start in life? And Jim actually was my research assistant at one point during my PhD. I'm sorry, this is a rather dark picture. He's in the front with his, he's rolled his sleeves up. The bedpans at the right of the picture are the bedpans of Sclerotinia sclerotiorum. And the reason I'm behind Jim, the reason Jim was helping me was we were doing a large-scale extraction, and the extraction involved chloroform, which is a pretty dense, heavy solvent, and using a 10-litre separating funnel. I think Jim was concerned whether I'd be able to do this, so he actually came into the lab. And obviously somebody else thought this was pretty unusual because they came and took a photograph. So that would be about 1975 in the labs. And I was able to find a couple of other pictures. Of course, we didn't have cameras in those days. Adrian Carpenter, who's in the audience. The rotary evaporator is probably mine. The books on the bookshelf are mine, definitely, because there's a copy of Vogel, which I've still got. Kirsten, who married Steve Potter, and Chris Fuchs were on the other side of my bench. This was in Lab 220. I don't know if the room numbers are the same or whether they've changed. It's sort of halfway down the second floor corridor. And then the only other photograph that was kind of presentable to show in public was of Ray Elliott in Lab 122. And of course, as we know, dear Ray is no longer with us. He is doing some literature, but he's eating at the same time as you did in those days. So that's it. That's pretty much the only record of my entire research career in Cambridge, but I can't not mention the book. Finian will remember the book. We had a big celebration in St. John's College. From time to time, Jim would say things like, I'm going home to work on the book, but he was often going home to actually dig his potato patch or something like that. That's not my copy of the book. I know somewhere I've got a signed copy, but I couldn't find it. So I had to take this off the internet. Classic little textbook. Right, okay, so now just a little segue into what did I do during my time in Cambridge. With the hindsight of 50 years, I think I did an awful lot. My first project was to work on sclerain. We saw the picture of the bedpans earlier on. And we started off doing some double acetate labeling studies to actually understand the pattern of incorporation of acetate units. And that's shown in the NMR spectrum in the middle. I think that this is a 20 megahertz spectrum. And the reason I think that is because if we flick on to the next picture, I did actually find the spectrum, which was, this is of a single acetate labeling experiment. If you look at the left hand of the picture, you can see five of the signals are stronger than the others. So this is a carboxyl labeled acetate, and it was done on a CFT20 instrument, and we used quite wide tubes, not 5, they weren't 5 mil, Jeremy, what were they, 12 mil, 20 mil tubes? But you had to have a lot of material to get this kind of level of, unfortunately, this is not dated, sadly. All right, so in the literature was a proposal that sclerain was composed of 2 polyketide chains, a triketide joining together with a diketide. Jim didn't believe this. He came up with the scheme that's shown on the left-hand side of the picture, that it was going to be a regular pentaketide polyketide biosynthesis, cyclizing to give an aromatic compound, which then underwent a rearrangement, a ring opening of the benzenoid part, an isomerization around the middle of it. Forget the fact that there's a carbon-carbon double bond there. We sort of fudged over the top of that. And then it would reform to make sclerain. So my actual project was to do the radio-labeling experiment with radio-labeled aromatic precursor, which is shown at the top right. Has anybody got a pointer? Or do I have to? Oh, thank you. Help me out here. the green button. I'm pointing the wrong way. Right. You can tell I've stopped lecturing, by the way. Does it actually work? I'm not sure it actually works, Vinian. All right, I'm going to keep talking. So I synthesized, and I'll show you in a moment the slide. I synthesized C14 labeled, there, thank you. Excellent. There. And incorporated into the fungus, and then we did some degradative experiments to prove that it was a specific precursor. I've got a slide of that, let's get to it. Okay, but before we get to that, this was just a brilliant find, right? Here we've got Jim's writing down of this new biosynthetic hypothesis, a single chain, starting off with the aromatic precursor, a ring opening, and then some kind of isomerization, and then closing back up again to make sclerin, right? And I think some of the people in the audience will know that what happened when I was doing my double acetate labeling experiment on the CFT20, I saw the spectrum on the screen, but then while I was trying to process it, I accidentally hit delete, so the data disappeared. So we knew that the incorporation had worked, but we hadn't actually got the physical evidence. Meanwhile, I'd popped off to Italy to do an Italian language course prior to my postdoc, and while I was in Italy, Jim got the spectrum rerun, probably by Brian Kreisel. And so I received in Italy the spectrum and the data, and annotated by Jim, Ave Maria, Dici, he didn't speak Italian, so Dici, not Dieci, fantastico, cheers, we must have a celebrazione. And then I tell you, the best bit at the top, I'm seeing doublets everywhere, and I've not had a drop to drink, honest, right? I had to dig hard to find that. All right, so the sclerin PhD, across the top, I show you 2 years of my PhD, C14 labeled methyl iodide, making the aromatic precursor, 37 milligrams, my goodness, the quantities that we worked with in those times, and then the degradation of the radio-labeled sclerin. The fungus converted the compound specifically into sclerin, and the classical Kuhn-Roth degradation established that because the degradation which pulled out acetic acid, only the methyl group of the acetic acid was labelled. Whereas if the fungus had actually just used that compound as a carbon source and generated methyl-labelled acetate, which would then have been built back into the molecule, the labelling pattern would have been completely different. So that was 2 years of my PhD, but what did I learn? I learned to do exquisite recrystallization and isolation of compounds in very small quantities, and that helped me a lot later in my career. All right, moving on very quickly here. By this stage, I think that Jim trusted me that I could actually get things to work. So he invited me to follow on from some of the work of Bobby Hill. Bob is the same generation as Dave Griffin. They were both 2 years ahead of me. And Bob was working on terrain and had done the double acetate labeling pattern. And Jim decided that we now needed to follow up by actually looking at the fate of hydrogen during the biosynthesis. So we were going to use deuterium-labeled acetate. And here is the actual diagram taken from our chem-coms. And Jeremy, I just thought I'd pick up here that somehow you must have been advising Jim about this in some way, because you are acknowledged, right? I want to just point to this picture here. This is the signal for C3 and C8, which were really close together. And the issue was going to be whether both of those carbons were deuterium-labeled or whether only one of them was. And the regular proton decoupled experiment, of course, which would the deuterium would lead to coupling of the carbon signals, created a very complicated spectrum. So Jim had the smart idea to actually switch off the proton decoupler so that the protonated carbon signals now shifted out, and we could see the presence of a deuterium triplet. And the next piece of paper I'm going to show you, it shows you Jim's hard work to actually identify that it was C8 and not C that was labelled. This was an absolute find. I had no idea that I had kept this and taken it to Australia and still had it 50 years later. So here he is, hand drawing that signal and looking at the chemical shifts in Hertz and just analysing the spectrum. So that was the level of detail that he used to go into. And at the bottom, I found a piece of paper in which he talks about going to give a lecture in London and that Cheryl had been helping him with preparing the diagrams. So I think there's quite a bit of history there. Right, okay. I'm very conscious of time here. When I came back to do my postdoc, I worked on, it was meant to be aspirone, but we discovered that the fungal culture also produced a lactone, aspilactone, and in fact there was also a stereoisomer called isoaspilactone, which I think will constitute my first piece of natural product structure elucidation. So of course we started off doing the double acetate experiment to look at the intact incorporation of acetate units. I think Tom Simpson was working on this in competition in Liverpool at the time. Competition, right, we're all now friends, but then it felt like a competition, right? And the question was whether there was an aromatic compound involved or whether it was just a linear precursor. I worked together with Richard Berreton on analysing the spectra in great detail and establishing that C3 and C, to improve the resolution of C8, C2 and C8 were originally part of the same acetate unit. They had been separated during the biosynthetic process, and that was consistent with cleavage across that carbon-carbon bond. So I think by now we've moved on to, that spectrum is not displaying, but it doesn't matter. So we've then followed up with some deuterium labelling experiments and established unequivocally that the biosynthesis went through a linear precursor and not through an aromatic precursor, because we picked up 2 deuteriums at the key position of interest, this one here. Now, the only reason I'm mentioning aspilactone, and remember that this work was being done in 78 onwards, is because recently I Googled aspilactone to see what might have happened since then. I know that a number of people in this room worked on aspilactone. I found a 2009 paper which just horrified me. 2009. I'll read it out. Not much is known about the biosynthetic pathways of isoaspilactone. Can you believe it? 2009. Except for a hypothetical scheme proposed by, who are James and Andrew? Right? Based on our results, we proposed, and they proposed an aromatic precursor. They proposed that 6-methylsalicylic acid was involved in the biosynthesis. So I had to do it. I wrote to them. This is a French group. I wrote to them. I said, did you by any chance ever read the papers that we published on this matter in 1977, 78, whenever it was, in which we convincingly showed that an aromatic precursor couldn't be involved in the biosynthesis, right? So after we've had a couple of drinks tonight, I'll tell you what the reply was. Right? And I think the message is actually, if you're going to, I mean, obviously they had no idea that there was an earlier literature. They cited Jim and Andrew Stukulski, 1991, but they just didn't pick up the earlier stuff. So there's a message there for students. Right, I'm just about finished. We've seen the picture down here, which is taken in my dining room of a time when Jim and Ruth came to Australia. They actually came with me to Heron Island on a field trip. Jim was once again my research assistant. He was the boatman while I was underwater. And I have very fond memories of that visit. I also found this picture of a party, a lunch party in Paulson Road. And based on Emily's age, we think that it must be 1982 or 1983, and it's possibly something to do with some kind of celebration or an acknowledgement that I was about to leave England and go to Australia. So we've got Finian and Marion, we've got dear Chris, Jim and Ruth, of course, and I've got no idea who these people are here, but there'll be people in the audience who know who they are. Right, so I'm not going to talk about the marine work in any detail at all, other than that I kind of cherished that the start I got here in Cambridge, just that crispness of thinking about problems. When I moved to Australia, it was to do a biosynthetic project to look at the biosynthetic incorporation of cyanide into marine isonitriles, which are quite biologically potent. This was my signature research, and it was done in the middle of the Great Barrier Reef, literally camping overnight on a pontoon. And subsequently, I then looked at a whole suite of other functional groups linked to terpene backbone. This was done in pre-genomic days. These days, we would do this piece of research completely differently. And in fact, within the last year or so, a group based at Scripps have started to answer the question about whether these terpenoid marine natural products come from the sponge host or from associated microorganisms. I couldn't do that, but that was something that I wanted to address all those years ago, nearly 40 years ago now. I was able to show an association of these terpene compounds with isolated sponge cells. We did cell separation experiments, but I couldn't prove biosynthesis. But it's really nice to see that that early work from all those years ago has been picked up very recently, and now it's clearly understood that these are sponge compounds. Right, and so I'm just about to finish, but again, another little highlight. Who would ever have guessed that I was in here, there, not down here, listening to lectures, that I would eventually not just end up on the Barrier Reef, but also that I would get a little marine animal named after me. So this is Moritigrella merrigarsoni. When the Journal of Natural Products did a special issue in my honour last year, which was just fabulous of them to do it, the black structures are structures that we isolated in Australia, but the yellow structures are structures on which I did the biosynthesis, and we can see aspilactone there and sclerin just having their place of honour. I think I wrote to Jim about this and said, I've got this little animal named after me. And he probably would have said, oh yeah, it's very, very suitable, Mary. It's very thin, it's a flatworm. And is it toxic? So I'm just going to stop there and just say thank you. Thank you to you, but particularly thank you to Jim and to Ruth.
I won't use the microphone, but thank you so much, Mary. What a brilliant start to the day. And it's fascinating seeing all of those notes. I'm incredibly impressed you've got those bits of paper. These days, everything